Assalamu alaikum wa rahmatullahi wa barakatuhu. I welcome all of you, my dear friends. My name is Nasir Ebadi. Today we are talking about ionization enthalpy or ionization energy. First, whenever we are talking about ionization enthalpy or energy, what do you mean by enthalpy? Enthalpy is energy which is given to a system or we are taking from a system. Enthalpy means energy. According to the theory of thermodynamic, energy is defined according to its sign into two parts, positive and negative. Whenever we are talking about positive energy to a system is an amount of energy which is given to the system. Amount of energy which is given to a system and so the system's energy increases. But whenever we are talking about negative energy, it's an amount of energy which is taken from the system, which is taken out from a system, and its energy decreases. Now what do you mean? For example, if I say positive 2 kilojoule, it means we are giving 2 kilojoule energy to the system. But if I write minus 2 kilojoule, it means we are taking out 2 kilojoule from the system. Now, if we are talking about positive energy, it means we are giving the energy to the system. So the system will absorb the energy. Whenever a system is absorbing the energy, it is called endothermic. But whenever a system is giving us the energy, on that case it is called exothermic. What do you mean by endothermic? Endothermic, it means that we are giving the system energy and the system is absorbing the energy. But whenever a system is giving us the energy, it means we are ejecting out the energy. That system is called exothermic. Now we are coming on ionization energy. What is ionization energy? First, I defined enthalpy. Enthalpy means sum of all energies to a system. Sum of all energies to a system may be from a system to a system or from a system. According to its sign, it is divided into two parts, positive and negative. Positive means amount of energy which is given to the system, and negative means amount of energy which we are taking. Both of them may be positive, may be negative. Both is shown by delta H. Delta H means energy or enthalpy. It can be positive and it can be negative. Now, what is ionization energy? Is it positive or is it negative? Is it endothermic or exothermic? Write it down, we will come on it. Have you finished? Okay. I'm deleting it all. Should I erase the board? Yes, why not, teacher? Okay, thanks. My brother, my sisters, my dear all friends from all over the world. Okay. Now, what's ionization energy? For example, we have got an atom. It has a nucleus, positive, and also orbits. Now, in orbits, we have got electrons, and in nucleus, we have proton. In here, this electron is revolving around the nucleus. If I ask you why the electron is revolving around the nucleus, you might answer that there is an energy between electron and protons, so that energy which bound the electron in order to revolve around the nucleus. It means we have got a bounded energy in which electron revolves around nucleus. Is it right? Yeah. Now, I want to ask you, can I eject this electron out? Can I eject it out? What would you answer? You might answer that yes, sir, you can. Then how? How it's possible? The way is, we should give some energy, that bounded energy, to the nucleus or for the atom, in order it will let the electron to be out from the system. It means how? You're answering by giving energy. This energy can be in light form, this energy can be in heat form, whatever it can, or maybe in electric field form. This energy can be in two ways: by giving heat, by electric field, and also it can be by what? It can be by heat, electric field, another way, light. In order to take this electron out, we should give energy. Now, maybe this energy might be in heat form or electric field, or it can be in light form. So, if we are giving this energy to the system will absorb the energy, and instead this atom let you, or this nucleus will let you to take this electron out. It means atom is like X, it is in neutral form. Now if we are taking this electron out, so the atom comes to be X positive, and also in this case some energy will be given to the system. It means a delta H is coming, and now this delta H is positive. Why? Because we are giving the energy to the system. So if you are giving the energy to the system, now what do we call it? This one is endothermic or exothermic? Of course, endothermic. Endothermic. This amount of energy is called ionization enthalpy or ionization energy. So what's ionization energy? Ionization energy or enthalpy is an amount of energy which is given to an atom in order to take an electron out of it. But there is a condition. In order to define the correct form of ionization enthalpy, what's that condition? We have got two conditions. First, atom should be in gaseous state. Atom must be in gas form. Atom must be in which form? Gas form. Also, gas form, it helps us, the atom must be in isolated case. What do you mean by isolate? It means an individual. Why? If we have the atom in liquid, if we have in liquid form or solid state, on that case, every atom is in a repulsion or attract force with the other atom. In liquid state and solid state, an atom is maybe in repulsion with the side atom or maybe with the with attraction. On that case, if we are giving this one an amount of energy, the energy will be lost between these atoms too. For this result, the ionization energy, the atom must be in gaseous state. Second, number two, atom must be in neutral form, neutral or ground state. Why atom must be in neutral or ground state? Because if we have, for example, X atom, which we are taking one electron out of it, it becomes X positive. But if we have X positive, now we are getting one electron from that one, it becomes X2 positive. In this case, we are giving an amount of energy which is greater than 0. In this case, also we are giving the energy which is greater than 0. But in the second form, the amount of energy is much greater from the first form. Why? Because, for example, we have got nucleus, we have got these orbits, we have got some electrons. If I'm taking out one electron, now the remaining part, this nucleus will have much effect from the previous one. For this result, it is too much bounded to the nucleus. So we are giving much energy. This is called successive ionization enthalpy. In successive ionization enthalpy, the first one is ionization enthalpy or ionization energy first, ionization energy second, and also it can be ionization energy third. So ionization energy second is greater than ionization energy 1. Why? Because ionization energy second, the electrons are much bounded or related to the nucleus from the atoms which they are in neutral or ground state. So then what's ionization energy? An amount of energy which is given to the system in order to take an electron out of it. This is endothermic or exothermic. It's endothermic. Why? Because we are giving the energy and the system is absorbing the energy, and instead electron is coming out. Now this atom must be, in which case the condition is atom must be in gaseous state. It means isolated. The atoms can be the atoms parts, it could be individual. And the second one, the atom must be in ground state or neutral state. Why? Because if it is in ion form, on that case we are giving much energy to the system in order to take it out. Now what's the unit? Unit, whenever you're talking about unit on the ionization enthalpy or ionization energy, the unit is kilojoule per mole, or maybe electron volt per atom. We mostly use kilojoule per mole. Mostly. It could be joule, doesn't mind. It means the unit of energy. If you are talking about 1 mole, then unit of energy per mole. If you are talking about just one atom, then unit of energy per atom. Or if you are talking about one molecule, it could be a unit of energy per molecule. I think you have got this one. Okay, take it right down, please. Okay, we have plotted the ionization energy first for the atoms which atomic number is from 1 up to 60. In here the graph is quite striking. It means we have to pay attention for that one. Now look, whenever you're going from hydrogen to helium, the graph is increasing. It means this axis is for delta H or ionization enthalpy or energy, and this axis is for Z or atomic number. What do you mean? It means whenever we are going from hydrogen to helium, for 1 mole of helium we have to give about 2500 kilojoule for 1 mole. Now whenever we are going from lithium to neon, the graph is increasing. It means for lithium we are giving a small amount of energy for 1 mole, but for neon we are giving about 2000 or maybe more than 2000 kilojoule per mole. What do you mean? It means hydrogen and helium, they are in one period. Hydrogen, we have helium. Whenever we are talking about lithium, after lithium we have beryllium, boron, carbon, nitrogen, oxygen, fluorine, and so neon. Do we have this one or not? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. It means they are in one period. This is first period and this one is in second period. Now whenever you are going from lithium to neon, the amount of energy for delta H or ionization energy, it is getting larger or smaller? Larger. For 1 mole of lithium we are giving 500. For 1 mole of neon, which we want to take out its electron from its most shell, then we have to give much energy. It means that whenever we are going from left to right, ionization energy is getting larger. Whenever you are going from left to right, ionization energy is getting larger. For hydrogen up to helium, for lithium up to neon, also from sodium up to argon, from potassium up to krypton, and so on. In here, we realize that helium, neon, argon, krypton, and xenon, they are noble gases. Now, noble gases are in which location? In maxima. It means they have the best electronic configuration. Now, we know that these gases, noble gases, helium, like neon, argon, krypton, and xenon, they have the best electronic configuration or stable electronic configuration. Then we realize that if an atom has the best or stable electronic configuration, so taking the electron out of it will be much difficult. We will talk about parameters for the next lecture, but now just we want to know what the graph is. In here, the second, for minima, we have hydrogen, lithium, sodium, potassium, rubidium, cesium. Lithium, sodium, potassium, rubidium, and cesium, they are alkali metals. Alkali metals, they are in minima. They are in minimum location. What does it mean? For lithium, we need, for example, 500. For sodium, we need lesser than 500. For potassium, we need, for 1 mole, lesser than sodium. And rubidium is less than potassium. Cesium is less than rubidium. What does it mean? It means in the group lithium, sodium, potassium, rubidium, cesium, they are in one group. Lithium, sodium, potassium, rubidium, and so cesium, they are in same group, first group. By going down to the group, ionization energy is decreasing. For lithium we have 500, for sodium we have lesser than 500, for potassium we have less than sodium, and for rubidium we have lesser than this one, and for cesium we have less than this one. Maybe you might ask what this one is. Let me take another marker. What this one is, what this one is, what this one is. If we are going from left to right, the ionization energy is getting larger. So why in here it got decreased? Why in here it got decreased? We will talk for the next lecture about this one. Now generally we are talking generally. From this graph we will take some important points and we will define the parameters which ionization energy regard to that one, and we can have more examples on it. Write it down. I want to zoom these parts, once for period and once for group. Write it. We will talk about it. Okay friends, we are zooming that graph. This one is atomic number Z, and this one represents ionization energy. Unit is kilojoule per mole. The first graph indicates period, and the second graph indicates group. This one is atomic number, and this one is ionization energy, delta H. Unit kilojoule per mole. Now look, in a period from lithium through neon, they are in one period. The amount of ionization energy is getting larger. What does it mean? It means for lithium, for 1 mole, we need 520 kilojoule. For beryllium, we need 899. And for boron, we need 801. Now, why this one happened? Why this one happened? Oxygen must be greater than nitrogen. Why? Because in the period, if we talk, we have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Since neon is on right side, this one is greater from fluorine. Fluorine is greater than oxygen. Oxygen must be greater than nitrogen, but we have a decrease in oxygen. Why this one happened? Why this one happened? We will talk for the next lecture. Also in the group, from lithium to cesium, we don't have any exceptions in here. For lithium, we need 520. Lithium, then we have sodium, potassium, rubidium, cesium. Now, in the group, if we are coming down, ionization energy decreases. For lithium, we have 520. For sodium, we have 496. And also for potassium, we have 419. It means we don't have any exceptions here, but we have this exception here. There we don't have, but here we have. Now why? For the next lecture, inshallah. For the next lecture, we will talk on that one. Did you copy? Okay, for the next lecture we are talking about ionization energy. For the second lecture we will talk about these exceptions and also the parameters which are related to the ionization energy, and we will have best examples. Follow us. We will meet as soon as possible. Allah Hafiz.